Hello, everyone, and welcome to today's two-part webinar series, Getting the Most and Best from Your Atomic Absorption System. My name is Christine Saffron, and I'll be your moderator today. I work on the marketing team here at PerkinElmer, and I'm very excited to be hosting this session today. I'm pleased to introduce today's speakers, Aaron Heinemann and Sarah Howden. Both Aaron and Sarah are the PerkinElmer experts on atomic spectroscopy, and I've put together a comprehensive presentation today that will take you through flame maintenance, both PerkinElmer AA systems, troubleshooting, and maintenance. Before I hand the mic over to Aaron and Sarah, I have a few housekeeping items to cover about this presentation and the GoToWebinar platform. First, today's webinar will be available on demand after the live session and will be accessible via email and our social channels. We would like to encourage you to share today's webinar with your colleagues and social networks. Next, we'd love to hear from you during today's presentation. If you have a question for our speaker, please feel free to send it through the Ask a Question tab at the bottom of your player. We'll be answering questions at the end of the session. If we don't get to your question during today's webinar, we'll be sure to follow up afterward. And last, for a limited time, PerkinElmer is offering an exclusive promotion on our newest AA spectrometers. Promos will vary by country. Please look for a follow-up email to this webinar with the details of that promotion, or you can request a quote on PerkinElmer.com right away. So without further ado, I'd like to kick things off by welcoming our inorganic product line leader, Aaron Heinemann. Aaron, over to you.
Thank you, Christine, and welcome everyone that was able to join us today. Thanks for joining. Glad to kind of kick off this flame AA maintenance, which is part one of our two-part series, as Christine mentioned, regarding maintaining your atomic absorption system. Most of you online, I believe, are users of PerkinElmer AA and or are familiar with PerkinElmer AAs over the years. So without further ado, I'm going to move on to the agenda here. So I'm going to just give a little back in memory lane, a little nostalgic historical information on our atomic absorption instrumentation, then get into what we're currently offering for atomic absorption instrumentation, talk about what current promotions as Christine talked about, and then we'll get right into the flame AA maintenance by Sarah Howden. So if we look back at 1961, PerkinElmer came to market with the Model 214. It was a double beam system that was modified for flame atomic absorption. You see, in a few years later, in 1963, PerkinElmer came up with the Model 303. This was a significant improvement in performance of the system, and as you see, the sales significantly increased during that time period. So there's a lot more instruments on the market during that time period. The 303 was quite revolutionary for the inorganic or elemental detection. I give you a little bit of a video that we put together for the 303. Yeah, so that kind of gives you a bit of an overview of an older 303 we actually had in the office. It's still looking pretty good condition, that one. So just an overview of the inorganic instruments from PerkinElmer. We have the ICP OES on your left, the PinAcle series AA, and sorry, I actually got mixed up, and then the Nexian series ICP-MS. Our automation offerings are PerkinElmer S10. We have a variety of auto samplers, the S10, the ESI DX series, Fast Ready systems, and the ASX series from CTEC that's available. We also have standalone flow injection mercury systems and Titan microwave preparation system available, and fast flame options for the AA. So our AAs can be upgraded to pumped introduction or pumped and valve introduction for a consistent and fast operation of the flame system, a fully automated control. Some software updates from PerkinElmer. We've gone to a platform we've branded it, we've called it Syngistix software, just as to get a way to unify our inorganic platforms, really with a modern software architecture. Updated our user interface to be more modern, of course, user interface with cross-tabular data view and simple export data to Excel. There's a variety of application modules depending on the software that we're talking about, and all the software has been updated very recently. Just this last year, a lot of the softwares have been updated for 21 CFR Part 11 requirements, and everything is in Windows 10 compatible, of course. We've also started to deploy what we call Radian remote monitoring services. Essentially, Radian is a software add-in to our Syngistix software that allows us to monitor instrument performance. Not really the performance, but the technical aspects of the instrument, like voltages, temperatures, flows, etc. So it allows us to preemptively monitor if something's going out of a threshold, be able to respond to that. And the benefit is that it's free, it's included in our instrument warranties, and it's included in all instrument service contracts as well. So essentially what happens is the instrument sends the diagnostic data to our cloud. We have a dashboard that our technical support center is monitoring. Once they get an alert that something's gone out of a threshold, then we contact the local service engineer, and then they'll typically call you and to make sure everything's okay. It's just simple kind of connection. Everything goes through a secure communication. It's all encrypted, standard encryption technology to the cloud. It's just diagnostic data, so it just has instrument serial number and the diagnostic data, nothing with the actual analytical data. That's not what we're monitoring. It's just the diagnostics on the hardware itself. Okay, so the PinAcle series is comprised of two different models. There's two primary models. We have our PinAcle 500 system, which is our flame-only system. And really, some of the unique features of it, it's a very small footprint that's obtained using fiber optic light transfer instead of mirrors. We also have we have two software flavors, two interface options. We have a simple touch-based interface, or if you want more full features and computer-based use of the system, we also have our ability to use the full Syngistix software for AA if that's required. Our system has full lamp and spectrometer alignment and auto gaining technology, so there's no user input there for aligning the lamps and any of the spectrometer. And then the PinAcle 500 was really designed to be robust in an acid type of environment. So all of our electronics in the shroud is coated with a filament coating so that we can prevent corrosion of the stainless and all the sensitive electronics in the system. Our burner assembly is very robust. It's all made of Radian and materials that will not degrade over time. And the burner head is made of solid titanium, again, for best corrosion resistance and to ensure greatest amount of robustness. The PinAcle 900 is the larger instrument of the two. It's slightly bigger in size, but it has more capabilities. As you see, it has a 8-lamp design, and it can come in flame only, furnace only, or in a stacked design where you have flame and furnace capabilities in one instrument. So in our single mode models, we have the PinAcle 900F, which is a flame only version. It just has the burner assembly, no graphite furnace installed, has 8 lamps, 2 EDLs possible. Then on the other side of the spectrum, we have the Zeeman THGA furnace only with the PinAcle 900Z. If we looked at our stack designs, there are 2 flavors here. There's the PinAcle 900H, which is an HGA type furnace with D2 background correction, and PinAcle 900T, which is our THGA type furnace with Zeeman effect background correction. So there's kind of 2 flavors of our stack design flame furnace. So the flame furnace has taken up a much smaller area than traditional flame and furnace, where there are 2 separate AAs or 2 separate systems, or next to each other. So this is the smallest system on the market of such design. Some of the unique features: it's an 8-lamp system. Again, lamp and spectrometer, auto alignment, and gain. All models come with this. The models that have flame assembly, it's automated head optimization. So the flame burner head will optimize maximum absorption for the particular element that you're determining. We have a furnace, stable temperature platform furnace with longitudinal transversely heated graphite atomizer that is on our Z and T models using Zeeman effect background correction. And on our H and T, as indicated, there's stacked integrated flame and furnace. The system does have a small footprint, again to do with the fiber optic light transfer, and there's optimized pre-aligned position for the furnace and flame atomizer. So they're essentially in fixed positions with the flame atomizer can be optimized from analyte to analyte if needed. The optical systems are both real-time double beam systems. They're using, as you see here, fiber optics to make them more compact and for improved high sensitivity and alignment in the system. We have a simultaneous measurement of sample and reference beams for correcting lamp modulation and fluctuations. And then it can be run in single beam mode when using a Zeeman for background correction. So the design provides exceptional analytical performance and long-term stability. Just to give you a bit of a background, I know today we're not talking about THGA or furnace, but just the difference between THGA and HGA is that we're heating the graphite tube transversely rather than along its axis, and that provides more even heat distribution along the tube compared to in the HGA style, avoiding condensation of your atomized sample. And just a quick update on promotions. For those of you that may not know, PerkinElmer offers value in any of your existing inorganic instrumentations, regardless of age, make, or model. So, please reach out to your local PerkinElmer representative, and take advantage of trade up or trade in offers that are available. And now I will transit over to Sarah. She will talk about flame AA maintenance. Hey, Sarah.
Hi. Yep. Hi, this is Sarah Howden talking now. So I'm going to talk about maintenance for your flame system. First of all, I do recommend that someone in your lab is designated to be responsible for the equipment, because if no one is designated as being responsible, it's probably not going to be maintained. All right, so I'm trying to, okay, all right. So filters. So here I have the locations for the 600, 700, and 800 filters. They're on the back of the instrument. And basically, if they look dirty, they are dirty. So I'm a big believer in making sure that your filters are kept clean. So you basically just pull off the plastic frame and the screen, and then you replace it with a clean filter. If you have the white filter, sometimes people will wash them, but you have to make sure they're absolutely dry, though, before you put it back on again. But it's a good idea to have lots of spare filters. All right, so this is showing you the filter on the 200-400. This is on the right-hand side of the system, and I have the part number designated here. And you just pull down the tab and remove the cover. And again, it's always a good idea to keep the filters clean. Now, on the PinAcle 900, you have the filter on the right-hand side. The left-hand side of the instrument, if you have a water-cooled ASCOM power supply, you don't put any filters in the filter holder. If it's an air-cooled ASCOM power supply, that's the furnace power supply, then you do need filters. And then in the back of the instrument, if you have a furnace unit, all that is an exhaust, so there's no filter there either. And then this is the location of the air filter on the PinAcle 500. This is on the right-hand side. Now, probably the hardest part about maintaining your flame system is removing the burner assembly. So on the 200-400, you pull up on the locking latch and you push the bar back to release the burner assembly. Then you also push back on the burner head latch so that the burner head can be removed. You remove the gas lines. You'll need a wrench in order to do that. And then you remove the nebulizer air line. And notice when you put the air line back on, the orientation of the nebulizer interlock magnet has to be up against the sensor, otherwise it won't see the presence of the nebulizer. You'll unplug the drain bottle connector, and then you remove the drain line from the spray chamber outlet. And you pull up on the nebulizer clamp, and then swing up the arm of the nebulizer, and then pull out the nebulizer. Now, when you put the clamp back on again, it's best to press the two sides below where it says push. So you don't want to push on the top part down when you put the clamp back on, because sometimes you can get the spring popping out that way. If that happens, the spring pops out, you just unscrew the screw and you put the spring back in again. And I have pictures later that show you how the spring gets in there. And you loosen the 4 knurled locking screws and remove the end cap. Now, when you put the end cap back on, you always cross-tighten the 4 knurled locking screws. And make sure you have a nice, tight connection between the end cap and the burner chamber. Then you remove the flow spoiler, and notice the orientation of the flow spoiler. Some people will have one of the vanes pointing straight up, but it's either straight up or straight down, whatever your preference there. But most of the U.S. documentation will have the vanes straight down. Now, if you want to remove the burner chamber metal collar, which is right behind this, the picture you see here, you can remove those 2 metal screws, and then you can remove that collar once you've pulled the burner chamber off its mount. So if you want to remove the burner chamber off the mount, you're going to have loosen the screw on the left-hand side and the screw on the right-hand side, and then you pull it off the mount, remove the locking collar on top of the burner chamber, and then you can remove the 2 screws under the bottom plate. And that way you've completely removed the burner chamber from the system. And then you would just clean it with laboratory soap and a brush. You can use an ultrasonic cleaner. And then make sure you rinse very well with DI water. Now on the 700-800, you're going to push back the burner head latch so the burner head can be removed. You loosen the 2 knurled knobs so that the burner chamber can be removed. You can remove the drain line and unscrew the drain connector. The PEEK drain fitting can be twisted off if it's installed. Some labs might not have it installed. And so the bottom right picture shows you with the PEEK drain fitting removed. Then the nebulizer clamp screw needs to be loosened to remove the nebulizer. When you put the nebulizer back on, make sure the clamp is over the flange of the nebulizer, so that way it's held securely in place. And again, you have the magnet on the sidearm of the nebulizer, where the aux air connects to the sidearm. And notice the location of the magnet. It has to be there because otherwise the system will not see that the nebulizer is installed. This shows you the sample compartment on the upper right after the burner assembly has been removed. And if you want to, you can remove the adapter plate on the bottom of the burner assembly. You just remove the 2 screws. And again, you would clean it the same way that you would the burner assembly on the 200-400. Now on the PinAcle burner assembly, you push back the latch to remove the burner head, and to remove the whole burner assembly, you push down the white button while you're pushing the locking latch back, and that removes the whole burner assembly. And then again, you would clean it like you would the other burner assemblies. Now I'm showing you the AAnalyst metal body nebulizer end cap. And if you look inside, you'll see the small hole in the end cap, and that is for the Pyrex impact bead. And behind that small hole, there's a plug, and you see the components of the plug on the bottom right. So you have the plug, and then if you look on the outside of the end cap, you'll see the plate that the plug goes up against. And there's 4 O-rings associated with this plug. There's one large O-ring right behind the plate. There's another large O-ring in the middle of the plug, and then you have 2 small O-rings on each end of the plug. And that's what the Pyrex impact bead seals in. So if a lot of times people forget about this plug, and so this could collect some rust if it has not been cleaned on a regular basis. Now, in terms of the O-rings, if you are using organic solvents, the end cap O-ring always needs to be changed to an O-ring that will hold up against organic solvents. My preference is the CalRes O-ring. And what I like about the CalRes O-ring is you can use it for both aqueous and organic solutions. But so always, if you're using organic solvents, you must change the end cap O-ring. If you have very aggressive solvents, you can also change the O-ring for the burner head and the O-rings for the nebulizer, which I'll show a little bit later. Now, I'm just showing the orientation of the plug in the end cap, just so you can see what it looks like after you remove the plate. And this is showing you the AAnalyst high sensitivity nebulizer end cap. And you see you have the spring behind that clamp. And again, if you push down on the top of the clamp instead of on the bottom part of it, it's possible that the spring could pop out. And this is just showing you the position of the spring. And it also, I'm showing you the inside of the end cap as well. And then this is the PinAcle metal body nebulizer end cap. And there's 2 different end caps. There's one for the metal body, and then there's one for the high sensitivity nebulizer. So I'm showing you the end cap that does not have the hole for the impact bead, but I'll also show you later the end cap that does have the hole for the impact bead. Now there are 5 O-rings on this end cap. 1 large one and 4 small ones, and I have the part numbers listed here, and they're made out of Viton. And again, if you're using organic solvents, you need to change those to CalRes O-rings. Okay. And you have the clamp on the left-hand side of the end cap, and that holds it into place. And then you have the arm that you swing over that will satisfy the interlock that will tell the system that the nebulizer is installed. Then I have another picture of this is of the high sensitivity nebulizer end cap, and notice it's a different end cap. It looks a little bit different inside. And of course, on the high sensitivity nebulizer, you have the impact bead. And again, you have your one large O-ring, you have the 4 small ones, and if you're using organic solvents, you need to change those to CalRes. And you're going to clean the end caps with laboratory detergent, a brush, and then rinse very well with DI water. Then this is showing you the metal body PinAcle end cap, which has the extra hole for the impact bead. And so I took off the cover of it on the front to show you what it looks like inside. So initially we did not have the ability to use an impact bead on the PinAcle metal body end cap, but now we do. If you are cleaning the burner head, and usually it's just cleaned with just lab detergent and a brush and then rinsed well. But if you are going to clean it with acid at all, and typically you'd use about 10% nitric acid for about 10 minutes, it's best to remove the magnetic strip and the 2 clamps and the 2 screws. And it's very important that the slot width does not get too large. If that's the case, you need to replace the end cap, especially if you're running with nitrous oxide. So in terms of cleaning the burner head, you can use the burner head cleaning tool, of course, with the flame off. And now this is showing you the AAnalyst metal body nebulizer, an exploded diagram. And the parts that get worn the most are the venturi and the needle assembly. And usually people forget about the insert that's inside the nebulizer. And usually I use the side arm of another nebulizer to push out the insert. And again, all of these O-rings have to be checked periodically. And if an O-ring is compressed, or if it's cut, or if it's dried out, or if it's sticky, or any other kind of damage, they must be replaced. So it's a good idea to check the O-rings on a regular basis. And you see that last O-ring, if you look at the picture on the right-hand side, you have that O-ring on the outside, and that's the O-ring that seals it to the end cap. A lot of people try to put it inside the nebulizer, but you must have that O-ring on the outside of the nebulizer in order to provide a tight seal to the end cap. Very important that you have a tight seal everywhere. And this is a description of when you would use the different types of metal body nebulizers. So the stainless steel is the standard one, but generally less than 10% acid, probably less than 5% acid, you would use the stainless steel. If you're using higher concentrations of acid, then you should go with the platinum rhodium one. And if you're using hydrofluoric acid, aqua regia, or high dissolved solids, then you need to use the corrosion resistant plastic nebulizer. And the 2 parts that are changed in order to switch between stainless steel, platinum rhodium, and corrosion resistant are the venturi and the needle assembly. And notice there's 2 different needle assemblies for the corrosion resistant one because the sample capillary is permanently attached to the needle assembly. So you have one with a standard length sample capillary, and then you have the one with the longer length if you're using an auto sampler. Now, I just want to go back to one item here that I forgot. If you are the high sensitivity nebulizer, if you're using aqua regia, you should switch the needle assembly to the tantalum version of that. All right, because the standard with the high sensitivity is platinum iridium. So you'll need tantalum if you're using acarija. And this is an exploded diagram of the high sensitivity nebulizer. And notice you have a spacer with the high sensitivity nebulizer. So the general rule on this, if you are running with a nitrous oxide flame, or if you're running an element that requires a rich flame, or you have a more complex type of sample, it is best to run without the spacer. And you see, this is a little bit easier in terms of taking it apart, but this is your exploded view of the system. And again, there are O-rings that you need to check on a periodic basis. And this is the PinAAcle metal body nebulizer. And I put two pictures here. On the left is with the standard O-rings. And then on the right-hand side, it's with the CalRes O-rings. So it's very nice. The CalRes O-rings are white so that you can easily tell that you have the CalRes O-rings installed. And again, if you have working with aggressive solvents, you want to use the CalRes O-rings. And again, the parts that you would change if you were going to a corrosion-resistant version of the metal body nebulizer or the platinum alloy version. It's the capillary assembly and the venturi that need to be changed. And this is the PinAAcle high sensitivity nebulizer. And again, you see on the left are with the standard O-rings, and on the right-hand side, it's with the CalRes O-rings. And then the last part is the drain bottle. Now, it's very important that the drain bottle is kept clean. So it's periodically you might have to remove the top part of the chamber and clean it out. Your system will work much better if the drain bottle is kept clean and maintained well. Now, another item we have, so what can happen with the line drain tubing is sometimes the liner can separate from the main tubing that you have. So we now offer different tubing where from the top of the drain bottle to the burner chamber. And that we have a thicker drain tubing without the liner, and that drain tubing does not crimp. And also, if you are working with very aggressive solvents, we also offer Teflon drain tubing. You have to cut it to the length that you need, but again, with very aggressive solvents, Teflon is the only thing that's going to hold up to very aggressive solvents. So we do have new drain tubing that's available. You can either call our 800 number to get a part number for that drain tubing, or you can contact your service engineer to get that drain tubing. And that finishes my portion of the presentation. So one last one. This is showing you what can happen if the liner separates from the drain tubing. And so there I do have the part numbers for the thick-walled unlined drain tubing that doesn't crimp, doesn't have the liner. And then we have the part number for the Teflon drain tubing that you can use as well. But of course, that's going to be much stiffer, so you do have to cut it to the length that you need. There. Now I will hand it over to Aaron again, or to Christine. I don't.
Thanks, Sarah. That was really good. I think we have time for some questions. Yeah. So we can go through some of these. We had one question from from an attendee. Hello, I use the PinAcle 900F, and I have a quick question regarding gas cylinders. What is the minimum or lowest pressure for acetylene and nitrous oxide before they are empty?
Do you want me to answer that one?
Yeah, Sarah. I mean, yeah.
Okay. All right. So if you have the standard sized acetylene tank, which is almost as tall as a person or approximately as tall, the tank pressure generally starts at about 350 psi. I prefer to change it out when it's 100 psi, but absolutely no lower than 85 psi. Once you go down to 85 psi, basically all that's left in the tank is acetone. And the reason there's acetone in the tank is because acetylene by itself cannot be at a higher pressure than 30 psi or it will spontaneously explode. And so that's why there's acetone in the tank. So at 85, basically all of the acetylene is gone. It's very important to have the tank upright in place 24 hours prior to using it because you want the acetone in the tank to settle to the bottom of the tank because you don't want the acetone to go into the gas box because it's a very aggressive solvent and it will damage the seals that are in the gas box. The line pressure should never be greater than 15 psi because again at 30 psi it will spontaneously explode, and so you want a margin between the point of where it's safe to use. So the general rule is never have a line pressure greater than 15 psi for the acetylene. It's possible that you could get a tank that's overfilled with acetone. So if you're aspirating nothing and you see a pink flame, that could be an indication that acetone is getting into your gas box. And again, it will damage the gas box. Now on to nitrous. Nitrous oxide, the standard size tank, will last about 10 to 12 hours of usage. The pressure is about 750 psi, and you will not see the pressure drop as long as there is liquid in the tank. So the nitrous oxide is in the liquid form inside the tank. So the only time you'll see the pressure drop is basically when the tank is empty. So when the pressure goes down to 500 psi, the tank is empty. And the line pressure for nitrous oxide should be the same pressure as your air pressure as well. And the back of the instrument will tell you what the pressure should be. So remember, you will not see the pressure decrease on the nitrous oxide until all the liquid is gone, and once all the liquid's gone, the tank is empty. Anything else to add, Aaron?
No, that's exactly it. No, that's great. Yeah, I prefer 100 psi on my acetylene as well. I don't like getting close to that acetone personally.
Yep, and that's an expensive repair bill that is not covered under warranty or under a service contract.
Yeah, and acetone, I mean, and acetylene's rather, rather inexpensive. Easier just to swap it out at 100 than to risk going down. And then next question. So we have another question. I was told by my PerkinElmer field engineer, service engineer, to not have the flow spoiler wing pointing directly down. Does it really matter?
Well, most U.S. documents have one of the vanes pointing straight down, but there are European documents that have one of the vanes pointing straight up. My preference is to have the vane pointing straight down. That's the way I was always taught, and that's the U.S. documentation all has that. And I've heard some people say that with more complicated samples, it's going to make more of a difference. But I'm okay with the vane straight down or straight up.
So, yeah, so it doesn't matter too much, right? From my experience, I remember it didn't matter too much, but I guess, yeah, for more complex samples, higher TDS, something like that could have an effect. Next question. Is it advisable to soak the burner head portion in acid solution? I use nitrous was a comment.
All right, I'll give my input on it. I think one of the things is to maintain your burner system on a regular basis. You don't wait until it gets really dirty. And all our documentation basically says to use soapy water, a brush. I really don't like the idea of soaking it in acid solution. There might be rare occasions when that's the only way you're going to clean it, but generally it's recommended just to use soapy water. I'll let you have your take on this, Aaron.
Yeah, I mean, yeah, for the most part, regular maintenance is always the best. So it's when you're done using it, it's cooled down, take it, I disassemble it, flush it right away. That's to me the biggest thing. I have soaked in acid, and typically it's not usually when I'm using nitrous all the time, but nitrous you have a lot of carbon deposition, and usually soapy water works fine in a brush. But when there's significant solids or salts from maybe geological samples or higher TDS samples, sometimes I've used an acid, and I've kind of just soaked just the very top of the burner head in acid, in a dilute acid solution. But for the most part, just regularly flushing the burner head is the key for me.
Now I have one more thing to add here. If you are running high levels of copper or silver, like in plating baths, it is strongly recommended that when you finish for the day, to remove the burner chamber and clean it, because otherwise you will have a buildup of acetylide compounds in the spray chamber that when they dry, they're spontaneously explosive. So this would only apply if you're working with very high levels of silver or copper, such as in plating baths. Then you must clean it basically every time you use it.
Yeah, I agree. That's very important. Next question. Is there any way we could get an emailed copy? Yes. So everybody will get, and everybody that registered will get email for a link to the recording for this webinar. How often do we need to clean each part of the machine? I have a PinAAcle 900. Really, it's based on usage for the most part. So it's tough to give a frequency. For the most part, for the burner assembly, I personally recommend cleaning it every day. I like to flush things with water, at least at a minimum with water, just to kind of get anything out of there. If you have a considerable buildup, you could use as Sarah said, a brush and soapy water. And then followed by DI water, just to kind of rinse everything out. Sarah, do you have any other recommendations to that question?
Again, it's going to be the type of samples you're running and how often you're running will determine the frequency. And of course, it's better to clean it more often than you need to than not enough, because if you wait till it gets really dirty, it's going to be very difficult to clean. You want to be very careful with the slot of the burner head. You don't want to nick it, scratch it, or anything like that. So you do have a burner head cleaning tool as well that you can use. And it's very important to check the slot width of the burner head on a regular basis, especially the nitrous one. But again, it's better to keep it clean than to wait till it gets really dirty.
Okay, thank you. And then let's see my questions. Got a couple more here. There's one on analytical data. It's kind of hard to do a question. There's a question on some drifting on a blank. Anything to help with that? That's going to be more specific to operation. So I'll get back to you, James, on the specifics there. Next question. I was told to have the wing off center, not up or down. So yeah. So I guess on the service engineer, somebody had told them to have the wing off center, not up or down. And kind of as Sarah said earlier, it's preferred to have it down, but I've personally not seen too much of a difference, as you rotate it. But it really would depend on the matrix being aspirated.
It might contribute to noise because I think it will drain a lot better if you have one of the fins straight down. I think you'll have better drainage. And you want to have smooth drainage. You don't want to see droplets going down the drain line. You want to see a steady stream. So it's possible that could introduce a noise.
That's true. Yeah, that is true. We had one question. Can I use a chemical resistant nebulizer with organic solvents? And then the second part of the question, which O-rings should I change when I use organic solvents with the AAnalyst 400?
So the standard nebulizer for the 200-400 is the high sensitivity nebulizer. So definitely, again, it depends on the solvent you're using, but it wouldn't hurt to change the O-rings to the CalRes O-rings with organic solvents. And it depends how aggressive they are. Always change the end cap O-ring, though, whenever you're running solvents. If you really have an aggressive solvent, you might have better results using the metal body nebulizer. And then, of course, you would have to change the end cap as well. But it's possible very aggressive solvents could have an effect on the high sensitivity one. So then you can go with the metal body.
Yeah. Next question. Just coming down. So I have a question. It's more of a service related, but occasionally I have noticed when igniting the flame changes from blue to quick orange. Does this mean there's uneven airflow? I see a spike in absorbance when this happens, and then it eventually comes to baseline. Typically, I mean, when I see that, that's usually some contamination in the burner assembly that kind of burns off. From my experience, it doesn't usually mean it's not uneven airflow. Sarah, what do you?
Yeah, usually the orange flame is indication of sodium. So I would take everything apart and clean it. And then usually if it's just salt buildup, you just need soapy water. There's always an ignition flow rate. It's possible that the flow rates that are on the burner control window are different than the default flow rate. So it's possible that after it ignites, it then changes to the indicated flow rate. So that could also be happening as well, that it's going to a richer flame. But I'd probably it's sodium contamination or some other kind of salt. So I would just clean everything.
Yeah, that's my experience. It could be a richer flame, true. We had a question: is there a brush supplied for cleaning, or a specific recommendation for a brush for cleaning?
You have to make sure that there's no metal exposed on the brush because you don't want to scratch anything. So as long as you're just cleaning with the bristles of the brush and not no exposed metal that's going to scratch anything, just a standard lab brush would probably be fine.
Yeah, I agree. I had a question regarding my stored results are encrypted. How can I view them in standard view in PinAAcle 500? I'm going to have to get back to you there, Michael, on exactly what that means. Typically, we never have a problem reviewing data or reprocessing data. So it'll depend on your software you're using, etc. So
I mean, they're going to be in the data manager. So maybe if you're trying to access them otherwise, you have to go into data manager in order to access the data. And you can either export it to an ASCII file that you can import into some other software, or you can use that data for report. It's possible if you're using, well, even with ES software, you should still be able to access the data through the data manager.
Yep, through the data manager, you should still be able to generate some sort of report. Okay. We'll get one more. There's one more question. So, and then we had a question regarding drifting with nitrous, but nitrous is a hot flame. There can be some drifting seen.
Well, one of the things I always recommend with nitrous is always, first of all, I'll always light with an air acetylene flame, because if there's any issue, either some kind of loose connection or something like that, I want to see it with an air acetylene flame before I switch to nitrous. So I always choose when to switch over to nitrous. And once you switch to nitrous, always look for that red or pink feather to make sure the flame is rich. You never want to run nitrous with an all blue flame. If it's all white, it's too rich and you're going to build up a lot of carbon. So you want to have a blue flame with the red or pink feather, but I warm up the burner head for a good 5 minutes before I switch over to nitrous, and that will minimize carbon buildup. And again, if it's all white, you're going to build up a lot of carbon as well. So it could be too rich, or you haven't warmed it up long enough. And then the other thing I use is I have a long carbon rod that I use to scrape off carbon while you're running. It's better to use that than a screwdriver, because a screwdriver can damage the burner head or scratch the burner head. So again, too rich or not warmed up will cause more carbon buildup.
Okay, that's the last question.
Awesome. Okay. All right, that wraps up our presentation on flame maintenance for your AA instrument. We look forward to the second part of this webinar series focusing on the furnace this coming fall. Have a great day, everyone.
Bye, thank you.
Goodbye.